So have you ever tried to like slice a watermelon and get it perfectly even?
Oh,
It's like you're always battling to make sure no one gets stuck with that sad little sliver at the end.
it's a delicate operation for sure.
Totally. And you know what?
What's that?
It turns out there's a whole lot of math behind slicing a watermelon fairly.
You're kidding.
Nope. I'm serious. I dove into this research paper called How to Fairly Share a Watermelon.
Okay.
And these researchers, they weren't messing around. They brought out the geometry, the calculus, like the whole mathematical arsenal just to solve this watermelon slicing problem.
I mean, I guess if you're going to do it, you got to do it right.
Right. They even modeled the watermelon as a spheroid.
Ah, the spheroid. Now that's getting a little technical for me. What exactly is a spheroid again?
Okay, so imagine a sphere like a basketball.
Okay.
Now, picture stretching it out a bit, like pulling from both ends.
So like a football kind of.
Yeah, exactly. And that stretched out sphere, that's your spheroid. The researchers even included this cool 3D watermelon image in the paper.
Oh, nice. You can really visualize it.
Actually, it makes
Yeah.
it so clear. And what's even funnier is they didn't even use a real watermelon for all their fancy calculations.
Wait, so they did all this with an imaginary watermelon?
Basically.
Hmm.
They used this simplified spheroid model.
Well, that's not unusual in science, actually.
Really?
No. Oh, yeah.
Yeah.
We use simplified models all the time. Think of it like a map. You don't need every single tree and hill to
I
navigate.
never thought of it like that.
It's about focusing on the essential information to understand something complex.
So it's like, even though Earth has mountains and stuff, we still use a sphere to study like its orbit.
Precisely. It's about finding that balance between accuracy and practicality, and this watermelon model does just that.
Okay, so they have their watermelon, or I guess their spheroid.
Right.
But like, how does that help us actually cut this thing into equal slices?
Well, that's where it gets really interesting.
Okay.
Yeah, so they wanted to figure out how to make those cuts across the watermelon.
The transversal cut.
Yes, exactly. They realized that even if you space those cuts out perfectly evenly, you're still going to end up with some slices that are bigger than others.
Which makes sense because the watermelon is thicker in the middle.
Exactly. And they really wanted to find a way to get those slices as close to equal as possible.
So what'd they do? Did they come up with some crazy complicated formula?
Well, they did use some pretty advanced math to figure it out, like calculus and integrals.
Okay, so maybe a little complicated.
A little. But the amazing thing is they were able to simplify it all down to this really easy rule.
Okay, now you have to tell me. What's the secret?
It's called the two-thirds rule.
Two-thirds rule. Okay.
Yeah, and it's all about how you measure where to make those transversal cuts.
So not just cutting it like a third, a third, a third.
Nope. Instead of dividing the whole watermelon into even sections, you're only dividing the distance from the center line to the edge.
Okay, I think I get that.
So let's say you're looking at the watermelon from the side, that oval shape.
Got it.
You're going to imagine a line right down the middle.
Right down the center, lengthwise.
Yeah. So to make your first cut, you would measure the distance from that center line to the edge of the watermelon.
Okay.
Divide that distance by however many slices you want. And then multiply that number by 2/3. That's where you make your first cut.
Oh, interesting. So you're cutting closer to the center than you normally would.
Exactly. And you do that same thing for each additional cut.
So if I wanted 4 slices, I would divide that center to edge distance by 4 and then multiply by 2/3.
Exactly.
Wow, okay. I'm kind of amazed that there's a mathematical formula for slicing a watermelon.
I know, right? It's pretty cool.
But why 2/3? What's so special about that?
Well, it all comes down to that cubic equation they mentioned in the paper.
The one that made my eyes glaze over.
Yeah, that one. Basically, it describes how the watermelon's volume changes as you move further away from the center. And that 2/3 ratio just happens to be the magic number that balances out those changes in volume to get the most equal slices.
Wow, that's pretty impressive.
Right. And they actually tested this out.
Wait, really? They really put it to the test?
Yeah.
Huh, they did this whole experiment, even filmed it.
I love that. They really wanted to get to the bottom of this whole watermelon slicing thing.
Totally. And get this, to measure the volume of each slice, they used Archimedes' principle.
Wait, really? Like the eureka moment in the bathtub?
Yep, that's the one. Except instead of a bathtub, it's a bowl. And instead of a crown, it's watermelon.
So they dunked the slices in water?
Exactly. Measured how much water was displaced and boom,
They
knew the volume.
That was so clever and
It-
so low tech.
Right. It's like you don't need a fancy lab to do some cool science. Sometimes the best tools are already in your kitchen.
Totally.
Oh, and speaking of cool stuff, did you know that watermelons are actually less dense than water?
Really? Is that why they float?
That's exactly why. The paper even said that the watermelon they used had a density of like 0.97 grams per cubic centimeter.
Which, thinking about it, makes sense. Watermelons are mostly water anyway, right?
Right. But then you've got those fibers and air pockets that affect the density too.
It's amazing how much science is packed into a watermelon.
I know. It's like we started off just wanting to slice this thing fairly, and now we're talking about density and ancient Greek principles.
It shows how interconnected everything is, right? Even something as simple as a watermelon can be a gateway to all sorts of cool knowledge.
Totally. And you know what's funny? The researchers figured out this whole volume thing, but they left one big question unanswered.
Oh, what's that?
The rind, how do you divide that fairly?
Ah, the rind. That's the real watermelon puzzle, isn't it? Some people love it, some people hate it.
Exactly. And it's not like you can just measure it the same way you measure the volume.
It's a challenge for future researchers to tackle.
Right. Maybe a future deep dive for us. But for now, I think we've earned a watermelon break.
Agreed. And next time I cut a watermelon, I'll be thinking about spheroids and the two-thirds rule.
Me too. Imagine whipping out a ruler at a picnic. People would think we're mathematicians.
We'd be the most popular ones there.
Right. Everyone wants a perfectly sliced piece.
Hmm.
But seriously, this was fascinating. It's incredible how curiosity can lead to such unexpected discoveries, even with something as everyday as a watermelon.
Couldn't agree more. It's a great reminder that there's always something new to learn, no matter how simple or familiar something might seem.
Well said. So, to all our listeners out there, next time you're face-to-face with a watermelon, remember those awesome researchers who went above and beyond for the sake of watermelon equality? And maybe, just maybe, give that two-thirds rule a try. You might just become the watermelon slicing hero of your next picnic. This has been fun. Until next time.
See you then.